This is project 1, video number 2, the one in which we write the code. I'm going to call my function. I'll have it return the variable evector, and I'm going to call the function itself evec. Takes charge q, and it takes a vector that contains the coordinates, but I'm going to call that rvec. Well, it contains a 1x2 array that contains the coordinates of a position in space, and I'm going to call it rvec because the x and y components of the position vector of the point in space are the same as the coordinates. And a tab over, and now I'm ready to go. K equals 8.99 times 10 to the 9th is the value I'm going to need. Put a semicolon on there so it doesn't print out. And I think that's all I had to initialize. Take those arguments, calculate our mag. I actually want to go to the main line here and say A equals, and I think our vectors go like this. I'm going to go 3, 4. Yeah. And then I think it's norm will calculate the magnitude of an array. So it'll do the square root of the sum of the squares of the elements, which in this case would be square root of 9 plus 16. Square root of 25 should be 5, if that works. Yeah, let's try one more. No, 1, 2 square root of 3 for a triangle. B equals 1, square root of 3. That's how you put square root in. Yeah, and then the norm of B should be 2. Okay, yeah, norm is what it is. Norm calculates the magnitude. So R mag equals norm of rvec. And then r hat equals, I choose to have some extra spaces in there. They're not needed, but optional. Rvec divided by rmag. Alright, then E vector equals K times Q, KQ over R squared, divided by rmag squared, and then all that times r hat. I think that'll do it. So I'll save it. And then try running it. Evec. And we're going to try 5 E minus 8 for the charge, 5 times 10 to the minus 8, and then rvec, I wanted 5 centimeters, 0.05, comma, 10 centimeters. Ooh. put that vector in there. 0.05 meters, comma 0.1 meters, which is 5 centimeters, comma 10 centimeters. Alright, let's see, and I get that E vector is equal to 1.6082 I, newtons per coulomb times I, times 10 to the 4th. So it's times 10 to the 4th, that would be 16,082 and 32,164 newtons per coulomb for the x and y components of E respectively. Let's see what I had in my test case. $16,082. It actually looks pretty good. And 32,164. 32,164. So I had some intermediate things that I could check, worked out here if that hadn't come out, but it did come out perfectly. So looks like this piece of code is working. And make sure I got enough semicolons in there. I should probably check that later on, but presumably if I run this with a semicolon at the end, I get nothing back, which is the way it's supposed to work. If I run it without the semicolon, I get the answer, which written in this 1.0 times 10 to the 4th times, and then whatever the whole vector is. It's a 1/2 vector. Okay, let's call that a wrap for project 1, video number 2.